Hello and welcome. Today I'm here again with a new topic, with something interesting and something really, absorbing for everyone who is interested in the world of synthesis, that is organic synthesis. So I selected something that I have experienced during my research journey. So I thought that I should share my experience of synthesizing a very useful monomer, which was further used for the synthesis of different diamines, and then it was condensed. This monomer was condensed with the number of diamines, and then I got the number of polymers, that is shift-based polymers, from this useful monomer. So today I thought that I should share my experience of synthesizing this amazing compound, this amazing monomer with you people, so that whoever is in the field of research, whoever is in the field of this organic synthesis, who is interested in synthesizing the world of monomers, who will definitely refer to my video, who will definitely share this video. So this is only for those researchers who are enrolled in PhDs and their MPhils, and in the MPhils also. So I'm Professor Dr. Moina Akhtar Mughal from Dr.Mchem Institute of Chemistry, University of St. Jamshoro. And today I'm here to share my monomer with you people. It's it's one of the monomer from my synthesized monomer series. I have synthesized number of monomers during my research journey, and this is also one of them. So I thought that I should share the preparation and how the reaction was progressed, and how I achieved this awesome compound, and what was the glassware used. Definitely, whenever we are doing the organic synthesis, we are, we know that we are going to use number of compounds, a number of chemicals, of course, and number of glasswares are used. And this is a specific type of synthetic procedure in which you are going to synthesize a monomer. So you need everything of the analytical grade, and the glassware is supposed to be all from that Pyrex brand should be used, everywhere. So I have used in my study, and in that time I was very much lucky to have that Pyrex made glassware everywhere. I used Pyrex glassware, condensers, beakers, measuring cylinders, and volumetric flasks, and watch glasses, and everything that was made up of glass was all Pyrex glass. So I was lucky to use that Pyrex glass. I don't know nowadays this Pyrex glass is there or not, but yes, in our times, this is the period of 4 or 5 years back. I did my PhD, and I have encountered all these. I used these all lovely equipment there in Dr. Mchem Institute of Chemistry, and in the Institute of Chemical Sciences, that is high tech, so University of Sindh. So I used to work and in the National Center of Excellence also, and some of my work was done at HEJ, University of Karachi. So that these are the areas where I've worked, and I'm lucky to work at these places to progress on with my progress my synthesis work there. So let's start our topic today. So for the glassware, of course I needed a condenser, because this is a condensation reaction, and we need to reflux our compound. So we do need a condenser, and we need a round bottom, three-necked round bottom flask, because one of the three there in the, as I mentioned earlier, also the flask has, I mean, three necks. Three necks are there. One neck is supposed to be for putting the nozzle of that nitrogen. Nitrogen nozzle is there to provide the nitrogen gas to create the inert atmosphere inside the inside that reaction mixture, and the other two are for one for the condenser, and the rest and the third one is for putting the thermometer. For the thermometer is supposed to be there to monitor the temperature range which is recommended for our reaction, and the temperature range here in the reaction is between 90 to 95 degrees Celsius. So I was very much used to focus on the temperature range. The temperature range should not never exceed above this, because one of my trials, because we as a scientist, we go through number of trials when we are synthesizing one compound. There are number of trials. It's not necessary, it's not sure, we are never sure that we are going to hit our target and we are going to achieve our goal in the first trial. No, it's not, never. It's never it's never like that. You have to go through number of trials to get the product you are looking for. So I also went through a number of, went through a number of trials to achieve these monomers, and I really worked hard on them, as my supervisor's lab office was just next to my lab. In the lab where we used to work, 3-4 students we used to work, our supervisor's lab was office was just next to our office, our lab. So he used to, his name, again I would be happy to take his name. His name is everyone knows him very well. He's a well-known man. He's an angel on this earth. His name is Professor Dr. Muhammad Howard Sahab. So his office was next to our lab. So he used to, go from our peep in that what are we doing? Are we in our chatting business, or we are doing? So we were always very alert and very, we were young and we were very active and we were very, energetic, and we were always like, oh my God, supervisor is there. But yes, we were very lucky that during the synthesis process, you need to ask each and everything. Just after 5 minutes, after 6 minutes, you have to ask your supervisor that to come and see that whether we are, on the right path or not. We are achieving there are so many difficulties we used to encounter at that time. We never knew that what is happening, because these were all our initial steps and nobody prepared these things before us. So we used to ask each other, and then we were lucky that our supervisor was very near, and we used to ask him, and he always welcomed us, and he always helped us to get through these tough times. So I'm thankful. I will remain thankful to him that whatever today we are, it is because of the God and because of Dr. Muhammad Howard that we got our, we achieved all our aims, and today we are, very happy. So thank you very much, sir. So this monomer also was, recommended by Dr. Muhammad Howard that I should follow the procedure, a general procedure to form the monomers, that is from marble and turquoise. So this is also one of those methods, general procedures for, synthesizing this monomer. So let's start and let's begin. Glassware I've mentioned, and the rest of the things, of course, we'll be needing thiophene. Today's monomer's name is 4,4-methylene bis 2-thiophene carboxylaldehyde, right? So I abbreviated it as MBTC, methylene based thiophene carboxylaldehyde, right? So, and 4,4, its actual name is 4,4-methylene bis 2-thiophene carboxylaldehyde. So abbreviation is always there, because the mouth is full of words, so we always abbreviated them. So this was MBTC, the monomer, today's monomer. So let's start with that. Yes. So This is my first slide I would like to share now. This is how I synthesize MBTC, as I just mentioned, that this was the term. It was a very lengthy name, so we just shortened it, and we always abbreviated our, the long chained compounds by, abbreviating them with some proper alphabet. So that was it, MBTC. The awesome monomer that yielded number of polymers, that is the ship-based polymers. This was the awesome monomer. That was the wonderful monomer that helped me out in synthesizing number of compounds, and I have done the characterization of this monomer. And through that characterization and through all those series of characterization steps, I got to know, and I was confirmed that yes, my monomer is for methylene base porphyraldehyde, because we used to do CHN analysis in those days from London, from England, Devon, right? And we used to send our samples there with their MK numbers. We used to write MK, and there was a number, and we used to send it by post, and we used to get our results, right? Whatever we prepared, we send it there for CHN analysis. At London, Devon, right? I still remember the name because I've mentioned in my thesis also. So the CHN was very authentic, and that was, after calculating the, after recording the melting point, that is the number one step. That is whether your compound is actually what you are looking for or not. Whether you have gone through all the processes of, stages of this synthetic steps you have done properly or not, or whether, because you need to, in this CHN analysis, you are going to get the percentages of all the elements that are there, that is carbon, hydrogen, and nitrogen, and oxygen. So we calculate our theoretical yield, and we send the compound, and then they send us back the found results, and the results are supposed to be matching, or they are supposed to be very, very close, or they are supposed to only a one digit was acceptable those days. So because we had a very tough supervisor, so he never used to, I have done a lot of repetitions in synthesizing one monomer. For one monomer, I used to, I took almost a month, 2 months, 3 months. Time was nothing those days when we were synthesizing monomer. So that's it. This is, a little bit, our students should know nowadays that how difficult it was to prepare an authentic compound that can, nobody can challenge it. Nobody can, say that, no, it's not that compound. You have done some blunder, or something is grossly wrong somewhere. No, we have the results from the places that are known for their authenticity. So that's why I mentioned it, I was lucky to get my compounds analyzed from those places. So this was today's little bit background about this compound, that is MBTC. So let's move to the most important slide. Synthesis of 4,4-methylene base 2-thiophene carboxyldehyde, MBTC. Now here in the first reaction flask, you can see a round bottom flask, right? It is almost of 250 ml, right? So I took almost 16.66 ml of thiophene to carboxyldehyde, or 2-thiophene carboxyldehyde, you can call it. And then I added into it 12.5 ml of acetic acid. Glacial acetic acid was used in it. And this was our mixture one, right? Then, as we've been shown in our, the procedure, that the temperature range should be between 90 to 95 degrees Celsius, and we knew it that the compound will be, on the hot plate, with the heating source was a hot plate. So we knew it that we are supposed to heat our compound, or the reaction will goes on, or the refluxing period will goes on for the period of 24 hours or 22 hours. The reaction will be completed within 24 hours. That is almost 22 or 23 hours we took in synthesizing one monomer. So we need to get our assembly assembled in that way. A hot plate, then over that hot plate, this round bottom flask, then over that round bottom flask we have the condenser, and then condenser was attached with different tubings. inlet and outlet for the water, and then of course the magnetic stirrer inside the inside this round bottom flask was placed there, so that the reaction should be stirred constantly for the period of 22 hours, 23 hours during the refluxing period, right? Okay, so this was it. In the next flask, okay, I took the other flask, or you can say I took a beaker. You can take a beaker, you can take a flask, whatever is, I mean, feasible for you at that time. And into that, I added trioxane. That is a white solid. It resembles, it has an odor of resembling to chloroform, right? And it was a whitish solid, so it's a primer. Okay, so I took 1.75 grams of trioxane and I dissolved it in 0.125 mL of sulfuric acid, that is concentrated sulfuric acid. I took by sucking it from the pipette, right? And 0.625 ml of glacial acetic acid added again to this reaction mixtures, right? So this was dissolved, these two, trioxane was dissolved in a mixture. Basically trioxane was not easily diluted in directly formaldehyde solution that was in the flask one. So we need to dissolve trioxane first in some some combo of acids, or a single acid or two acids, so that first it should be properly dissolved, and then we used to add that mixture dropwise to the first reaction mixture containing thiophene to carboxyldehyde, and sorry, I said furfural-dehyde, no, thiophene to carboxyldehyde, first flask that is there. So we have to, prepare two different mixtures. That is, number one mixture was your thiophene to carboxyldehyde plus glacial acetic acid, and then the second flask I prepared was, or a beaker you can take, dissolved trioxane in almost how much, 1.75 gram was dissolved in 0.125 ml of sulfuric acid and 0.625 ml of acetic acid. Okay, and then it was stirred constantly with a glass rod. I stirred it till it was all dissolved. The trioxane was no more there. Then I poured this reaction mixture dropwise. Here you can see I've written dropwise in a very slow manner, one by one, into the reaction mixture. That is this one, containing 16.66 ml of 2-thiophene carboxyldehyde and a 12.5 ml acetic acid. So in a dropwise manner, I took a little bit time, this has to be done slowly and gradually. When you are being told to do dropwise, that means dropwise and constantly swirling the flask, dropwise and swirling the flask as much as you can, because it's fixed on with the stand on the hot plate, so it's a bit difficult to swirl the compound, but you have to loosen the clamp so that you can easily swirl the compound, right? And your heating has already been started, right? A slow heating, a hot plate is supposed to be slow in the initial stages, not supposed to be regulated in that way that it should reach the temperature 90 to 94 degrees Celsius. No, in the initial stages it is a little bit slower, and then slowly we increased at the temperature till it started refluxing, right? So this was done in an inert atmosphere. That means in the reaction flask, this is here I've shown a single neck flask, but it's actually a 3-neck flask. As I just mentioned before, that I insert the nozzle of a nitrogen gas to provide the inert atmosphere to this reaction mixture. So this whole, bunch of compounds were now dropped into the reaction mixture containing thiophene and glacial acetic acid, dropwise, slowly, gradually, and with constant swirling of the. I took almost 10 to 15 minutes in, transferring this reaction mixture, these compounds, these combo of so many acids and trioxane to my reaction mixture contain of thiophene and glacial acetic acid mixtures, right? So this was, a little bit tiresome. This was a little bit, time consuming, because there's always, you have to be patient. Your patience is really judged at this moment, that you are patient enough and you are following all the steps the way you are supposed to do it, and the way you are supposed to, you're told to do it. So you have to do it that way, otherwise you will not get the results in that manner. Because I just mentioned it to you that a researcher, a scientist, a new researcher, or an experienced one, you can never, you're sure about it that you are going to get your product on the very first trial, within the very first trial. No, there are a number of trials, and in that sense you waste a lot of compounds also. Your compound is wasted also. But you know, we knew the way to recover back our compound that was used. So we used to recover back also the compound that was used. So we did number of trials. One trial failed, no problem. Second trial failed, and we are going through these same series of steps, all these steps. Just look at these steps. These are very lengthy steps, okay? But we never lose hope. We never, we were never down. Yes, I was a bit, down at that moment, but then again, I got up with the same energy that I have to do it. I have to do it. I'm going to prepare something nobody has prepared before. So I am going to do it. And this is how I achieved, and how I was lucky enough to get, the results I was looking for. So this is it. So now let's back to our reaction scheme. So now again, where we have left, okay, so it was the inert atmosphere. Now the temperature was set up to stand between 90 to 95 degrees Celsius. The hot plate was regulated in that sense, and the magnetic stirrer was, working, and the reaction was constant. The reaction mixture was stirring, constantly being stirred by that stirrer inside it, right? And then, okay, I left it there. It was supposed to be left for the period of 24 hours, okay? That refluxing is supposed to continue for the period of 24 hours. Fine. Okay, so now after 22 hours, this mixture, I found a mixture, right? It was, I saw the mixture. It was a bit oily, and whenever you find your product a little bit oily, you feel a little bit, something, a fear comes to you that maybe you are going to get the product you are looking for or not. You have some doubts. So I was already mentally prepared, because our supervisor, again, the credit goes to him, he guided us that yes, the product is oily, we will do something to wash out the oil, right? And we are going to recover the product. We are going to get our precipitates. Fine. So now, according to our procedure, the mixture was then, this whole reaction mixture was poured slowly and gently into an ice cold distilled water, that is 250 mLs were taken. As I was, pouring it into that reaction mixture onto that crushed pieces of ice, I was stirring it with a glass rod, constantly stirring and pouring and stirring and pouring and stirring. And this was, done within a time period of almost 10 to 15 minutes. I took in, pouring this mixture dropwise to this reaction mixture onto the crushed pieces of ice, right? And as this was again a water insoluble compound, so I got to get, I was hoping to get something, right? I'm not telling right now because the step is again a little bit far. So now according to our procedure, we have to keep this this reaction mixture for another 10 hours. So again, I put a lid over it and I kept it there. It was kept for the period of 10 hours, right? It was stirred occasionally in between, and then again it was kept at one side, not touched again and again, not to be disturbed again and again, and the process of precipitation was supposed to carry on during that time period. So again, for the period of 10 hours, it was left. So see how lengthy it was, what a patience a scientist should have. Oh my God, yes, it was the time. We have a lot of patience. So, right, so after 10 hours, again, I got to get, I was so, anxious to see what happened to my reaction mixture. And yes, I found that the whole precipitate, the whole reaction mixture that was floating 10 hours before was now settled down at the bottom, right? And that was settled down. It was something heavier, right? It was something heavy, so that's why it settled down, right? And a few droplets of oil was seen at the top. Okay, fine. I filtered the product, right? I first stirred it. It was a vigorous stirring was done, and then it was, I mean, filtered off. It was filtered off. Then it was washed with yes, because I knew that I saw a few granules of oil, I mean, floating at the top. So I washed it with distilled water, then with ethanol, and of course, then with diethyl ether, right? Because these are the solvents, these are the combo of solvents that are always used when you are washing your compound. So your compound needs to be washed out before, I mean, before drying, before getting full the drying process and the recrystallization process. It is supposed to be washed properly. So I washed it properly with these three solvents, and one by one I took one. First of all, distilled water. There's always a sequence how you are going to start the washing with. Of course, from the water, that is distilled water of almost few mls, then ethyl alcohol few mls, then of course diethyl ether, right? It's also few mls, and then I was left with beautiful dark brownish precipitates of 4,4-methylene bisphosphorylaldehyde, thiophene 2 carboxyldehyde, 4,4-methylene bis 2 thiophene carboxyldehyde. This was my second monomer which I prepared, right? So the color, and as in the first, initially I discussed with you people my first monomer, that was furfurylaldehyde. It was a bit different from that one, as in that experiment, in that synthetic process, we omitted the addition of sulfuric acid because of the speeding up reaction, resulting into a polymer compound within a period of synthesize within a period of 4 to 5 seconds, or maybe hardly 10 seconds. It was prepared, and it was, I mean, nothing. It just turned into carbon. It looked like that it is just like, you know, piece of carbon. There was nothing in it. And then we have gone through all the process, CHN and everything, and it was not formed, right? It was not the proper way. So we omitted sulfuric acid in that reaction in the preparation of 4,4-methylene bisphosphorylaldehyde. But now in this one, as according to the recommended procedure, we, of course, here you can see we used 0.125 ml of sulfuric acid. That is only a very few, some you can say a drop or two of concentrated sulfuric acid was used in this reaction mixture. So nothing happened, and the reaction progressed, and this reaction mixture was progressed smoothly. The refluxing period was completed within the period of 24 hours, 23 hours. The temperature range was constantly monitored, that is 90 to 95 degrees Celsius. And then, of course, I was, I got my monomer that is dark brownish, that was dark brownish in color, was recovered. Then after washing, it was filtered off through suction filtration. And during the washing also period, in the washing time also, we washed it when it was assembled with the Buchanan's funnel. And then of course the filtration was accomplished, and the product was now ready for recrystallization, because now we had our product, the crude product, the raw product was there, and it need to be purified before it could be progressed further for further studies, for further characterization processes. Needs to be recrystallized again. So again it was recrystallized, and I've chosen number of different solvents. We used to take few granules of our compound, and we used to take a minimum amount of some solvent and try to dissolve it, and then we see that, oh, it's not dissolving, it's not, or if it is dissolved, we are not recovering back the precipitate. So we change the solvent. So now we have, after a number of trials, I have chosen, or ethyl alcohol was chosen as the, solvent, the proper solvent that could recrystallize and that could recover back my compound into its form I was looking for. So I got my product back. It was ethyl alcohol from ethyl alcohol, and then I kept it. It was dried in the oven for about 8 hours, around 8 hours, and at the temperature of rounding of 70 degrees Celsius, right? So for the 8 hours, it was inside the oven, and it was being monitored. We used to open and see that whether it's okay or not. Fine. And this is the here we have reached now. After I mean crossing so many hurdles, look at here the arrows and everything, and then now we are here at this stage. The product was recrystallized with ethanol and dried in oven at 70 degrees Celsius for 8 hours. So after that, fine. I got my monomer, right? After this step, I got my monomer in the perfect form, in the most purest form, in the form I can use it further for other studies, for characterizations. Of course, first initially the characterization steps that includes the FTIR, the CHN analysis, then FTIRs, then UV visibles, then of course proton NMRs, then of course thermogravimetric analysis, then viscosity measurements. I've done all the characterizations over this one monomer. On all my monomers, I've done all these characterizations. They were being characterized through all these various techniques that were available during those days. Okay, so I got my compound that was supposed to be, I mean, of this formula. You can see here the structural formula of my compound. This is 4,4-methylene bis 2-thiophene carboxyldehyde, right? And this is called MBTC. Okay, so here, and its melting point, as I recorded, it was above 390 degrees Celsius. So it has a very high melting point range, you can see, right? So in this way, I got my polymer. I got my monomer, and then this was monomer after going through number series of characterization steps. It was now confirmed as a pure monomer, and we were very happy that we got our product. I mean, yes, we have accomplished. We have encountered lots of hurdles. Lots of steps were failed, and we again did it. I again did it. I'm saying we, but it's actually we means I and my supervisor. That he again said, go and do it again. It's not correct. Again, your CHN is not correct. Go and do it. I have this bunch of papers of CHN analysis of one compound, each one compound, so many trials of CHN analysis. And CHN analysis, you cannot do it directly. You have to go through all these steps to reach to that point when you are going to analyze your compound through CHN analysis. Nowadays, I don't know people are doing it or not, but in those times, we cannot progress further until or unless our CHN was not up to the mark we are looking for, or up to the, I mean, recommended procedure. It was supposed to reach that, I mean, ranges of percentages. Okay, so I got my compound in the end, monomer, that was synthesized. Now I'll jump to my next slide. So this was the actual compound, the monomer that was synthesized for 4-methylene bis 2-thiophene carboxyldehyde, MBTC. And you can see here that it was a bit shinier also. You can see some shiny particles there also. These are not white. This was pure brown, dark brownish coffee colored compound. And because we know it as a chemist that whenever your product is having 2 or 3, I mean, shades inside them in the final product, that is this one, you're having 2 to 3 shades of that color, that means some impurities are still there. You need to recrystallize it again to get the exact one color. It is supposed to be one colored compound. It is not supposed to be a bunch of colors that are mixed together in the end and you are getting your product. No, it is supposed to be one color and a single colored compound, right? And so this shine is, this is all shine, right, of that camera snap I took that time. So it was pure brownish color, and that was the monomer I was, I got after, after so many steps, after passing through so many hurdles, I got to get this beautiful compound. And as I just told you, its melting point was also recorded. It was almost reaching 390 degrees Celsius, and its percentage yield was almost 83%. So that was all about this beautiful monomer. I hope you have followed all the process of the synthesis by Marble and Torquay. And yes, it's during those days, they used to prepare monomers with this method. Nowadays, advancements are there. Of course, people are making and synthesizing monomeric compounds with different techniques, but this was also one of the recognizable techniques, which I applied, and I got to get my compounds in a wonderful way. And then I condensed this monomer with a number of other compounds to prepare other series of compounds, which helped me out to carry out my research journey, right? So because I was purely a pure organic, I will belong to pure organic synthetic region, so that was my area of research. So I synthesized this monomer. So I thought I must share with you today, and I must show you that the series of my monomers, this was one of that compound, right, which I prepared, that is MBTC 4,4-methylene bis 2-thiophene carboxyldehyde. And I was very happy that yes, I prepared this compound, and I got the beautiful results after a lot of hurdles. So never lose hope. That's my message for that today, that never lose hope. There's always a door open for you somewhere. So God is great. He helps the people who are looking for his help. So that's my belief. So thank you very much for watching my video, and thank you very much for sparing few moments to get to know how I prepared my compound. And if you like it, you can share it with your friends, and if you like it, you can apply. Those who are in the process of synthesizing monomers or shift-based polymers or resins or polymeric compounds, they can go for this method also. They can try this method also, and I think this is I think maybe it will work for them also the way it worked for me. So thank you very much. I hope I was successful in sharing my views with you people as a researcher, as a scientist, because I have spent a lot of years in synthesizing a number of compounds. I've synthesized almost 14 compounds, 14 polymers in my MPhil, and I've gone through all the characterization techniques. And in my PhDs also, I have also prepared a number of compounds, which I'm not going to name right now because it will take a lot of time in discussing each and every compound. So it was, something very, very tough, and it was very, and I was a hard worker, and my supervisor never wanted me to leave. And he, in the last years of my synthetic journey, he was also saying that do one more part also, but I said no, I am done. I am done with my research journey now. I am over, because it's tough. It's tough. Organic synthesis is tough. You are encountering a lot of carcinogenic solvents, and God knows how we are going to end up. So this is something very scary also. Now when I thought about all those moments, I feel scared that God can only save us for getting all those dreadful disease, because we've been inhaling all those carcinogenic solvents years and years. We have been inhaling, and we were careless. We were scared. We were careless. We never look for the fume hoods, or everything is supposed to be there, and then we are supposed to. No, we were careless. So God is there. He will save us now also. Thank you very much. And inshallah, next, hopefully I will come up with something interesting, something more knowledgeable for you people to understand, and to to get some knowledge from, because the way I got privileged, I hope I can, I mean, share my experiences with the people who are interested in my lectures. Thank you very much.